Okay, so good morning, everyone. I'm Deepak, and I work in Intel, basically network platform group. And today I'm here to give a brief overview of the Cryptodev work which we are doing in DPDK. So we are around 4 minutes late, so I'll try to accelerate the stuff a bit. First of all, legal disclaimer: you can see this in your free time. On the agenda part, I'll keep it short, not going very deep into the details and keeping things simple. We'll go in the order of, I'll tell what is basically Cryptodev. There might be people who already know about Cryptodev. There might be people who are new to Cryptodev. So basically, I'll give a brief snapshot of what Cryptodev means in a slide. Then we'll go through the current status. The current status stands for 1607 release. What's in there, then future releases and future plans for Cryptodev. As Tim has already showcased some of the plans, but I'll go through some small details in there. The next thing is a brief overview of hardware-based virtualization, especially for the NFV use cases, and how you can leverage, how application can leverage basically the virtualization in hardware. Then the next is performance. It will be not the absolute performance, but relative performance, which we measured based on software PMD and PMD, the quick access PMD. Last but not least, the summary. If you have any other questions we can of course discuss in the end, and you can stop me in the middle also, and I'll be here. Starting with Cryptodev. In short, basically Cryptodev is a framework which is there to process symmetric crypto request. You can see in the right hand side the image as a DPDK application. It's similar to Cryptodev API. We have Cryptodev API, and then we have various PMDs. The first three PMDs like Kasumi PMD, Snow3G, and ASNI multi-buffer PMD, they are all software-based PMDs. And then we have Intel Quick Access Technology PMD, which takes advantage of Intel Quick Access hardware. In terms of API, the API supports both hardware and software implementation. We have algorithms which are supported in hardware and not in software, and software in hardware. We are trying to close the gap in every release. We try to catch up. It's a poll mode driver infrastructure, same as Cryptodev. So the polling is done to get the response from the PMDs. So if we're developing an application based on Cryptodev, so each PMD, as of now, all the 4 PMDs, they support the full Cryptodev API. I'll give a component-based overview of Cryptodev API in my next slide, but each PMD has the full support of Cryptodev API, but it might not support the whole algorithms. Assuming if in case of ASNI multi-buffer library or the PMDs, we have certain constraints. We don't have some operations like cipher-only operations or hash-only operations. So we do support ALG chaining and all. So these type of constraint in QAT, we have different constraints which we have. The important thing, the last bit, is the query capabilities. So we have query per device. Of course, you can query for device details, what it supports, which algorithm it supports, what key size, in terms of cipher, you can query for which algorithms are supported per PMD. You can ask for what is the cipher size maximum which is supported with the minimum cipher size. In terms of hash, you can of course query for digest size, AAD data, and all those things. In terms of brief overview, the main components in API, there are 8 main components, which are device management, device capabilities, algorithm definitions, session management, in which you get OPEX structure and define all your details there. We have queue pair management. We have device stats, operation provisioning, operation processing, and Q and DQ. There are some of the features which are there from Cryptodev, so they are similar there. In terms of symmetric algorithm definition, you can always query for what algorithms are as of now supported in any of the PMD. In op provisioning, you can fill up your operations with different information about IV size or key size and all this thing information. With divide stats, you can query for like various stats which are like similar to Cryptodev API. So these are the main components of Cryptodev API. So if you're developing an application, then you'll go use one of the APIs to create your application. Moving on, as of now, the current status for Cryptodev for like Cryptodev is in terms of cipher algorithms. There are some supported in both hardware and software. For example, in terms of like cipher algorithms, we have CBC, CTR for 128, 192, 256 bit support. We have Snow 3G, which was done in 1604 release, which has support on both hardware and software. Kasumi F8 is done in 1607. Null is done in 1607, which is only as of now a software PMD support. There's no Intel Quick Assist like support as of now for that. Moving on to the hash algorithms, we have SHA-1, 224, 256, 384, 512 support in there. AES XCBC is there, Snow 3G, UIA 2 mode is there. Hi, yeah? Oh, sorry, I can't hear you.
Sorry, any plans for the FIPS certification of these algorithms?
For FIPS certification?
FIPS.
No, as of now. Okay. I'm not aware of that, sorry. So, in terms of AED algorithms, we have GCM support. There is 128, 192, 256 supports. 192 and 256 is just supported on hardware. It's done in a way we are trying to support all the algorithms which are important from the perspective of IPsec and NFV use cases. So in future, we are always adding more and more support so that we can have complete symmetric crypto support, but things might change based on feedback, based on like requirement from people and community. So like this is what we have as of now. In future, basically 3 major things which we plan to do. First and foremost is like performance. For the QAT optimizations, we have already started this work some days back. We have sent a major refactored patch which is optimized for especially for the Quick Assist PMD. Of course, there are software PMDs optimization by enabling new software libraries on the network builder website, which you can always download and you can utilize those. For refactoring and code cleanup is always like continuous process which is there. Like performance and other things are also in parallel to the next generation of devices also like will be there. Some of the optimizations are based or focused on like keeping in mind the next generation of products. In terms of algorithm support, especially in the QAT PMD, you will see a lot of activity for 1611 release. Basically, we'll have like Kasumi implementation, all like cipher only, hash only, alg chaining support in there. We'll be having a GMAX support, MD5 HMAX support, SHA-224 and 384, as I told in the last slide, it's not there as of now, but it will be there. Null and triple S like CBC support will be there. In terms of software PMD, there'll be Zook, there'll be like triple S, like of course like CBC support. In terms of hash algorithms, we'll have MD5, SHA-1, 224, 256, 384, 512 support, AES GMAX support. The interesting point in this is in software PMD, we already have SHA support, SHA-224 to it, but they are through Intel high performance libraries, like multi-buffer libraries. What we're trying to achieve here is we are trying to have another option through a libcrypto library to enable these algorithms and provide a support for people who don't want to use Intel software libraries or don't want to use a like Quick Assist like solution, so they can have that functionality on there. We have seen some people querying for that support in the recent people like send emails in the like community. So we are trying to address those in there. The next thing, as I was talking to like some people, there are more discussion on scheduler. We are thinking of having a scheduler which is multi-op scheduler with main thing is like the ordering should be maintained in there. So what we want to achieve here is mainly we're trying to use both the hardware and software solution to the best of its potential. We want to maximize the like performance, so we are still investigating some things. We are doing some background work to make sure whether it makes sense and we'll have some discussion within the like community for this. So these are the three main things in future we are planning. Things might change, of course, like we might add new stuff, we might delete this stuff, like some of the stuff in here. So we'll keep it posted to the community. Next, a very brief overview of hardware-based virtualization. I just wanted to have showcase this, especially the figure is important to us. So instead of text, the main thing is like figure here. So we have on the host, we can have quick assist physical function driver. We support two types of driver as of now. One is if you have kernel 4.4 and above, you can of course use a quick assist driver, which is a stock kernel driver. You can expose your VFs through that, and then it will work fine. If you don't have kernel 4.4, if you are using the earlier version of kernels, you can of course download the QAT PF driver from 01.org, which is our open source network center website, where you can find more information about quick assist drivers and devices and which are supported on which OS and all this thing. So you can use either of both options in there. But the important part is when you go to the VM or the guest OS, when you have a DPDK application running in there, you don't need a quick assist driver in the VM. You just have to use your IGB UIO driver. You bind it to the VF through IGB UIO driver, which are already exposed from the PFs, and it can support the quick assist. And this is especially valid for quick assist application. We have the important use case which we tested is we have 3 different OS, assuming you have Fedora, you have Ubuntu, and you have FreeBSD. For some OS and for one some particular versions of these OS, there might not be a quick assist driver, but you don't need to have a quick assist driver if you are using that into VM. So the quick assist driver is only to be used in the host, and then you can expose the VFs through VTD and IOMU technology, and you can use the pass-through to just send all the requests from the VM to the host device. In terms of performance, we tried to showcase what happens in software PMD. So as of now, we have support of Intel performance libraries, which is there on the network builder website, which you can always download from there by registering there. But as of now, we have ASNI multi-buffer libraries, which is mainly for SHA algorithms, GCM. We have Snow 3G support in there. We have Kasumi support in there, which you can have it there. In future, I think Zook will be there. So when we have 16.11, you'll get Zook in from there, from Intel network builder website. On the QAT web PMD, what we measured on the host is what we can expect. But the important part was to see whether how we are working in the virtualized environment. Are we really degrading on throughput, or we have seen on the offload cost? So what we have seen in our experiments is the throughput and offload cost remains largely the same. They are very minor effect on there in the virtualized environment. You can see from there that the main difference which we encountered in the virtualized environment is address translation, which is done through VTD IMU. The only hit which we can get on the performance or throughput in virtualized environment is the rate of IoT LB cache misses. So if we can optimize the code in a way that there are less cache misses, then the throughput will improve, and you will see there is a less and less degradation in throughput in there. So these are mainly the performance factors in there. Of course, when we send the new patches for the performance optimizations, we'll always have a use case of that it works absolutely fine on the virtualized environment, taking care of the NFV use cases. The next graph, basically, it shows relative performance between a software PMD and which is ASNI multi-buffer library, and for a quick assist technology if you use it. It's particularly done for AES 128 CBC in SHA-H1 mode, and this is just to showcase that how it works with different packet size. So increasing the packet size, of course, you can leverage the advantages which quick assist have to offer. For small packet size, you can have software PMD as well as quick assist PMD. These are the tests which we are doing to see whether it makes sense to have scheduler in there. As you can see from the graph, that for small packets like 64 bytes packets, the improvements shown by Quick Assist and Software PMD are like relatively less. So, like, does it make sense to have a scheduler in there to have like leverage both of these at the same time and can increase the throughput in there? Or for the large packets, we have done some packets for like up to 2K, and we have seen how Quick Assist and Software PMD work together. So this is the test which we did to see what we're doing and like does it make sense to have all this in and to plan out like future work for us. The next thing is basically like summary what I've told in this presentation. The first thing is important thing to note is as of now we only support in Cryptodev, it's only supporting the like symmetric algorithms. So there's no support of algorithm asymmetric algorithms as of now, which might be a plan maybe in future, we don't know. The next thing is the API currently supports both hardware and software. In terms of hardware, we have Intel Quick Assist like technology like support in there. For software, we have Intel high performance library like support which is there. So it provides like seamless implementation there. From the features side of from the future release, future plan website, the slides, we have healthy pipeline of features which at least from Intel side we will be like contributing to Cryptodev API. And last but not least, it's the hardware. If you want to have major boost in the like performance for like depending on the use case and the packet size, we can have you can of course use hardware implementation like for the same. This is all like what I have. Any questions I can take that, or if you want to discuss anything on future crypto work which you are trying to improve, and if you have any questions on that, you can always come back to me. That's all from my side. Thank you.
Any questions for Deepak?
Yeah. Sorry, can you please have the mic?
The testing you did, was it done on Coletto Creek, that type of PCI, or was it done on Rangeley?
No, it's more for like current generation of devices. We can have more details in there, but it's for like current generation of device, but mainly like Coletto Creek. Yeah.
Okay, so you didn't do a Rangeley?
No.
Without getting into code names or QAT versions or that kind of thing, is there a commitment to get support for future devices in the QAT line, or even aligning what you've done in the software crypto PMD with the recently open sourced ISAL? ISAL, is that right? Yeah.
Yeah, we
So
call
that's
it
two
ISAL.
questions. ISAL, yeah.
Yeah, for like software, we have some plans to integrate some of the features which are coming in the next generation of devices. So, and also the like same thing applies for the Quick Assistant like devices.
Right. The question is really sort of how fast will the PMD support follow the availability of those devices? Is really
think this is-
commitment level on Intel's part.
I think this is more into, we'll see how far, like we'll always try to do as fast as how the like things are moving, but like depending on licensing and other issues, we have to see what we can support. So there's no commitment as of now, but depending on if everything goes okay, we are more than happy to implement like solution as soon as there's a like solution there.
Yeah, so the plan would be to support new hardware as soon as it's available, but
Yes.
then we need to look at the mechanics of that, the specifics of that. So it's not an absolute guarantee, but that would certainly be the intent, that when there's a new piece of hardware available, we'll have support for
Yes.
that ready to go in Cryptodev.
Question. Hello?
Yeah, sorry.
Hi. Do the PMDs actually support segmented buffers?
Like pardon me, sorry?
Like multi-segment MBuffs?
No.
No. So we'd have to flatten.
Yeah.
Is there integration planned with OpenSSL?
SSL, we are working on some support through the libcrypto, but we have to see which version of SSL we should take. Like, should we take the latest version, which is, but there are some
Yes,
constraints
the
in
latest
there.
version.
So we're trying to see which version fits or integrates well with like within that, and how much we can support from their perspective, or because it's, and which, so basically it's into development stage as of now. So if we'll see, it makes sense to base the libcrypto library on particular OpenSSL like version. Our priority will be to have on the latest and greatest SSL version, but like things might not work on the latest one. So like it should be like relatively the newer version of it.
Is it because of adoption that you might wait, or do you think there's actually some implementation issues?
It can be both. Adoption, how many people are moving to the latest version, but if there are very few people, then does it make sense to move to that version or stick to the version which most of the people use? And for the implementation details, we have to see what we can do there.
Thanks.
No problem. Yeah. Oh, here. Sorry.
Yeah, it seems like you have two categories, software or hardware, but it seems like there's really three, software, hardware, or a quick assist.
So basically, as of now, in terms of hardware, we only have quick assist implementation, and as like Jaren and Hemant says, when we have future like crypto devices in there for hardware, we might change how things work in like crypto API.
So then if it's software but using special instructions, that's still software?
Yes,
in your
it
definition?
will be
Okay.
purely software based, yeah.
Okay, so there's no like pure, are there pure C implementations of any of these algorithms, or are they all expecting Intel specific instructions?
So for if you want to use special instructions for the like current generation of the course, or like Broadwell, or as well, we have the like multi-buffer library which is there, which is specially optimized for these purposes. But if it's not for these, then we are trying to have libcrypto like support, which will be through OpenSSL. So there'll be no pure C based implementation there for the PMD.
Okay.
Okay, thanks, Deepak.
Yeah, okay,
Very
thanks
good.
a lot. Thank you.